Hi, I hope you're doing well today. We're going to talk about Unit 14.2 data distributions and the effects of outliers. With data distribution, we describe this in three ways. So a data distribution can be described as symmetric, skewed to the left, or skewed to the right. And this distribution depends on the shape of the distribution. So let's look more specifically at what this means for each of these three. Starting with symmetric. In the histogram and dot plot that are below, this shape is referred to as being a bell shape and is symmetric, which means exactly half of the data points are to the left and exactly half are to the right of the mean. We often refer to this as being a normal curve or a normal distribution. So if we look at two examples with this, think about what it means to be symmetric. If we were to fold the histogram, if we were to fold the dot plot, everything would line up. We also need to talk about the best measure that we would use and the best measure of spread that we would use. So for symmetric, the best measure of center is going to be the mean. The best measure of spread is going to be our standard deviation. For skewed to the right, fewer data plots are found to the right of the graph towards the larger numeric values. So describing what this means, we have a tail. The tail of the graph is pulled towards higher or positive numbers or towards the right. So we're going to have a tail that's pulling to the right. The mean typically gets pulled towards the tail and is greater than the median. So if we look at this with graphs, here is your tail. Most of the data is in here. For the dot plot, here's your tail. Most of the points are located in here. The best measure of center for skewed to the right is your median. The best measure of spread is your range and your interquartile range. Skewed to the left. Fewer data plots are found to the left of the graph, which is towards the smaller numeric values. We describe this as the tail of the graph is pulled towards lower or negative numbers, or we're taking the tail to the left. The mean typically gets pulled towards the tail and is less than the median. So if we look at some examples, here's your tail. Most of your points are in here. Here's your tail. Most of your points are located in here. For skewed to the left, the best measure of center is your median. The best measure of spread is your range and your interquartile range. So let's look at some examples that describe this data distribution and the best measures. So number one, what is the shape of the distribution shown? We do have a tail that is to the left. So this is going to be skewed to the left. When you are skewed to the left, your best measure of center is the median, and the best measure of spread, you would use both your range and your interquartile range. Let's look at a second example. What is the shape of the distribution shown? So most of the numbers are located in here, which means your tail is towards the right. So this is skewed right. What measurement of center and spread would be best to describe the data? So for skewed to the right, your center is the median, and your best measure of spread is both the range and your interquartile range. If we look at a third example with data distribution, what is the shape of the distribution shown? This example is symmetric. We often describe this as normal distribution. Normal distribution. What is the approximate mean of the data set? Your mean acts as your median. So here in the middle, between 130 and 140, we could approximate your mean to be about 135. The second topic in this unit, 14.2, is the effect of outliers. So let's define an outlier. An outlier is a value in a data set that is much greater or much less. So it's a value in a data set that is much greater or much less than most of the other values in the data set. We determine outliers using three things. We need the first and third quartiles and your interquartile range. So we need the first and third quartiles and your interquartile range. We also have some formulas we're going to use. A data value X is an outlier. X is either going to be less than quartile 1 minus 1.5 times the interquartile range, or X is greater than quartile 3 plus 1.5 times your interquartile range. So let's look at an example. It says we have 13 employees at a small company making the following annual salaries in thousands of dollars. So we have 13 employees. We have annual salaries that are in thousands of dollars. And we have the 13 salaries located here and in the dot plot. Does the data have an outlier? Okay, it looks like it does here. We need to determine if it is actually an outlier. So we need quartile 1, quartile 3, and your interquartile range. You can use your calculator to find these three things. Plug this into your list and then calculate your statistics. Quartile 1 would be 35. Quartile 3 is 47.5. Your interquartile range, subtract the 2. Alright, now out of the two formulas that we have, quartile 1, quartile 3, we're on this right hand end, so we're on the upper end. So let's look at the one that uses quartile 3. So we suspect that 150 is an outlier, so let's let X be the 150, and we're going to plug in to the formula here. So 150 is greater than quartile 3 plus the interquartile range times 1.5. 47.5. If we multiply, we get 18.75. Adding, we get 66.25. This is a true statement. So we could say 150 is an outlier. Statement is true. The salary that is the outlier would be $150,000. So this means most of the employees, 12 of the employees, are making salaries located in here. Let's look at a final example. This is where we're going to compare two sets of data. It says Emily played 4 rounds of golf and then played her lowest round of golf with a score of 80. So I said we have two different sets that we're going to use. So we have 4 rounds of golf, and then she plays a 5th round that has her lowest score of 80. The scores of the first 4 rounds and the lowest round are shown in the dot plot. Which of the following were affected by her lowest round? Right. I'll put this information in the calculator. Here's the 4 rounds. To get the 5 rounds, I included the 80. Calculating, you get your mean for 4 rounds is 93. For 5 rounds is 90.4. So the 80 does have an effect on the mean. The median for 4 rounds is 93. For 5 rounds is 92. So the 80 does change the median. The mode, you have no numbers that repeat. Standard deviation. For 4 rounds, you have 2.58. For 5 rounds, 6.23. There is a change due to the 80. For the range, take the smallest number, subtracted from your largest. 96 minus 90 is 6. Included in the 80, 96 minus 80, 16. There is a change. Interquartile range. For 4 rounds would be 4. For 5 rounds would be 10. There's also a change. So the only thing that does not have a change, since she included her final score, which was her lowest of 80, is the mode. Everything else does have a change with it.